Welcome to a new video of Simplexity. In this video we are going to solve the LeetCode problem 74, search a 2D matrix. The problem gives us a matrix where each row is sorted in ascending order. The first element of each row is greater than the last element of the previous row. Essentially, this means we can treat the matrix as a single sorted list. Our job is to find out whether the target is inside the matrix. In the first example, you can see that the rows are sorted in ascending order, and the last element of the first row, so 7, is smaller than the first element in the second row, and that's 10. And the same for the second row. So basically you can see this matrix as one sorted list. To solve this problem, it's helpful to understand what binary search is. Binary search is an efficient algorithm used to find an element in a sorted array or list. It works repeatedly, dividing the search interval in half. If the value of the middle element is equal to the target, we have found our element. If the middle is smaller than the target, we ignore the left half. If it's larger, we ignore the right half. This process continues until the target is found or the search interval is empty. Here's how the matrix algorithm works. First, we calculate the total number of elements in the matrix. That's m times n. And then we define two pointers left and right to represent the range of indices we are searching within. Initially, left is set to 0 and right is set to m times n minus 1. Now we begin the binary search. We calculate the middle index, mid, as left plus right divided by 2. But remember, since the matrix is two-dimensional, we need to map this single index back to the 2D space. We do this by calculating the row as mid divided by n and the column as mid modulo n. This gives us the exact position of the middle element. Next, we compare our middle element, midval, with the target. If midval equals the target, we return true as we found the element. If midval is less than the target, it means the target must be in the right half of the current range, so we move left to mid plus 1. Otherwise, the target is in the left half and we move our right pointer to mid minus 1. Repeat this process until left exceeds right. If we exit the loop without finding the target, we return false. This approach works in O of log m times n time, which is efficient given the sorted nature of the matrix. Thanks for the support lately, guys. We're almost at 200 subs. If you're interested in another topic or have video suggestions, please write them in the comments. I'm thinking of starting a Java or JavaScript crash course. Let me know what you think about it, but that's it, and I see you next time.